which will give us 45. Collecting like terms, we have 1.5 W equal to 45 minus 31.5. 1.4 W is now equal to 13.5. Our W, making W the subject of the formula, we have 13.5 over 1.5, which is now equal to 9 Newton. Example 8. A uniform beam AF having 80 Newton at point A, 0.6 meters from the vacuum B, having a reaction R1 and another mass of 300 Newton hanged at point C, 1.2 meters from the focal point B and 1 meters from the fulcrum point D, having a reaction of R2. Another 100 Newton having a distance of 0.5 meters from the fulcrum D. In the diagram above, we are asked to find the reaction R1 and R2. Solution. Summing up the reactions and the weight together, we have R1 plus R2, which is the two reactions, equals to the weight of the which is acting on the beta rule, which is 80 plus 300 plus 100. Therefore, R1 plus R2 is equals to 480. This will be our equation 1. Anticlockwise moment equal to clockwise moment. Then, taking our reaction at the point R, or the reaction R, we have that 300 Newton at the point C is covering a distance of 1.2, which is going which is the clockwise moment times 1.2, which is the distance from the force 300 to the fulcrum point B or R1. Then another 100 Newton force, it's going clockwise too, times the distance from E to B, which is 0.5 meters plus 1 meters plus 1.2, which will give us 2.7 meters. Then plus another reaction, which is equal to the anticlockwise moment, which is 80 Newton times 0.6 meters from the reaction R1, and the R2, which is not known, which is going anticlockwise, times the distance from R2 or DB, which is 1 plus 1.2. Then we have 360 plus 270 is equals to 48 plus 2.2 R2. Summing up, we have 630 is equals to 448 plus 2.2 reaction. 430 minus, collecting like terms together, you have 630 minus 48, which is equals to 2.2 R2. Subtracting, we have 582 is equals to 2.2 the reaction. Therefore, making the R2 the subject of the formula, we have 582 over 2.2, which will give us 264.5 Newton. from the equation 1, we have that R1 plus R2 is equals to 480. For substituting the value of R2, we have R1 plus 246.5, which is equals to 480. Making R1 the subject of the formula, 264.5 crossing over will become minus. Subtracting the values, we have 215.2 Newton, or sum of force anti-clockwise and clockwise direction is equal to 0. Therefore, minus 8, that is the reaction at the point, is times 0.6, that's the distance from the reaction, 0.6 plus 300 times 1.2 minus R2 times 2.2, which is the distance, the reaction from the reaction, times 100 plus 100 times 2.7, which is not equal to 0. If we make the computation, we still have our R2 equals to 264.5 Newton. Example 9. A force P pull a body at an angle of 30 degrees. If the length of the body is 3.5 meters, 200 Newton hanging at 1.5 from the point where the force is pulling, and 100 Newton hanging from a point from 200 Newton at a distance of 1.5, and the remaining length is 0.5. We are asked to find the value of P if the body is in equilibrium. Solution. Since the body is being pulled at an angle, and the hypotenuse of the angle is being known, and we need to find one side of the angle, we now say that using trigonometrical law, we have that y over 3.5 equals to sine 30. Making y our subject of the formula, we have that 3.5 sine 30 is equals to 1.75. Then clockwise moment equals to anti-clockwise moment, or anti-clockwise moment equals to clockwise moment. Then to solve for P, we have that since the side where the force P is pulling the body is 1.75, is equals to 200, which is the distance from where the body is, times 2, which is 1.5 times 0.5, which is 2, plus 100 Newton, which is the remaining distance of 0.5. Then P times 1.75 is equals to 200 times 2 will give us 400, plus 0.5 times 100 will give us 50. Then P times 1.7 is equals to 400 plus 50 will give us 450. Making P the subject of the formula, we have that 450 over 1.75, which will give us 257.1 Newton.